Today we will discuss flow volume loop. This is the last part of spirometry lectures. So before you proceed further, I would request you to please watch the previous parts, which are available on my Instagram page as well as on my YouTube channel. You can find the link in my Instagram bio. By definition, flow volume loop is a graph where you can plot the inspiratory and expiratory flow on the y-axis against the lung volume on the x-axis during the forced inspiratory and expiratory maneuvers. The significance of this loop is that the changes that occur in its shape during spirometry can help in the diagnosis and localization of airway obstruction. A normal flow volume loop has a triangular expiratory flow limb and a semicircular inspiratory flow limb. Let's recap this picture from our previous lecture. You can clearly appreciate that in obstructive lung disease, the total lung capacity and residual volume are more than in the normal lung. On the other hand, in restrictive lung disease, all lung volumes, including total lung capacity and residual volume, are smaller as compared to the normal pattern. Now consider a patient doing spirometry. You ask him to blow out forcefully. The total lung capacity is 6 liters, so the air will start coming out from here up till the residual volume, which is almost 1.5 liters. So this is how a normal expiratory flow limb looks like. The expiratory flow rate is faster in the beginning and then it reduces over time. And this peak is the peak expiratory flow rate. Now the patient breathes in, pulling the air from 1.5 liters and filling it up to 6 liters. This is the inspiratory curve. Inspiration is generally a slower process than expiration. That's why there is a difference in the shape of their curves. In restrictive lung disease, there is a restriction to lungs expansion. So the lung is shrunken and the lung volumes are reduced, but there is no obstruction. So the shape of the loop will be same, but its size will be smaller. Also, in restrictive lung disease, the loop is shifted towards the right. That's because the lung volumes are lower than normal. For example, in this case, the residual volume is 0.5 liters instead of 1.5 liters, and total lung capacity is 2.5 liters as compared to 6 liters. In obstructive lung disease, you have to remember a few things. First, you should know that due to obstruction in the airways, the patient has difficulty during expiration rather than inspiration. That means that the inspiratory curve will be normal. Secondly, because the lungs are hyperinflated in obstructive lung disease, the residual volume and total lung capacity are higher than normal lung volumes. So the curve will be shifted towards the left-hand side, and it looks like this. This concavity in the curve is because during expiration, the already obstructed airways become narrower and narrower over time until they collapse and are unable to throw out more air. It increases with the severity of obstruction. The last category to discuss is extrathoracic airway obstruction, which means obstruction anywhere starting from nasopharynx up till trachea. It could be due to a tumor in the upper airways, fat, pharyngeal muscle weakness, vocal cord paralysis, or tracheal stenosis. Normally, when we breathe in, the air enters through the nasal cavity and then it reaches the alveoli. But if there is obstruction anywhere here in the upper airways, then the patient will be unable to inspire efficiently. So the air will move very slowly through these blocked areas before reaching the alveoli. However, during expiration, because the lower airways are open, the air will quickly move out initially. But then it will slow down due to the obstruction in the upper airways. This means that both inspiration and expiration are affected in extrathoracic airway obstruction, but inspiration is affected more than expiration. So both the expiratory and the inspiratory limbs are blunted in extrathoracic obstruction, but the inspiratory limb is affected more than the expiratory limb. Here's a small quiz. I'll give you 30 seconds to interpret these flow volume loops. These are the answers. I'm sure you got them right. That's it for today. I hope you found this lecture useful. So please like the video, share it with your friends, and don't forget to follow me. Take care. God bless you all.